VLAN, Virtual Local Area Network, is a logical segmentation of a physical network into multiple virtual networks. It allows you to group switch ports into different broadcast domains, regardless of their physical location. VLANs provide several benefits, such as improved security, reduced network congestion, and simplified network management. Let's look at some VLAN concepts. 1. Grouping. VLANs enable you to group users, devices, or departments based on their function or requirements rather than physical location. For example, you can create a VLAN for the sales department and another VLAN for the marketing department, allowing them to be isolated from each other while still connected to the same physical network. 2. Broadcast domain segmentation. By segmenting a network into VLANs, you can reduce the size of broadcast domains. When a broadcast message is sent within a VLAN, it is only received by devices within that VLAN, reducing unnecessary network traffic and improving network performance. 3. Security. VLANs provide enhanced security by isolating sensitive data in separate VLANs. For example, you can create a separate VLAN for financial transactions or confidential information, restricting access to authorized users and preventing unauthorized access. 4. IP voice traffic separation. VLANs can separate IP voice traffic from data traffic. This segregation ensures that voice traffic is prioritized and delivered with low latency and high quality, separate from other types of network traffic. 5. Troubleshooting and failure. Isolation. By dividing a network into VLANs, you can reduce the size of the failure domain. When a network issue occurs, it is easier to locate and isolate the problematic components, speeding up troubleshooting and minimizing downtime. Now, let's explore an example to illustrate these concepts. Example: grouping users by department. Suppose you have a company with multiple departments: sales, HR, and IT. Instead of having all the employees connected to the same broadcast domain, you can create separate VLANs for each department. This way, the sales team can communicate within their VLAN without impacting other departments, enhancing security and network performance. Before implementing VLANs, it's important to understand the different types of network traffic. This knowledge helps determine how to place devices and configure VLANs effectively. Let's explore some common types of network traffic. 1. Data traffic. This includes user-generated traffic such as file transfers, web browsing, and email communication. Data traffic is the most common type of traffic on a network. 2. Voice traffic. IP voice traffic carries voice communication over the network. It includes voice over IP, VoIP calls, and other real-time voice applications. By separating voice traffic into its own VLAN, you can prioritize it and ensure high-quality communication. 3. Management traffic. This type of traffic is used for network management purposes, such as device configuration, monitoring, and remote access. Management traffic allows network administrators to manage and troubleshoot network devices efficiently. Different types of VLANs serve specific purposes and have unique characteristics. Let's explore some common VLAN types. 1. Data. VLAN. A data VLAN is configured to carry user-generated traffic, separating it from other types of traffic such as voice or management traffic. It ensures that regular data traffic remains isolated within the VLAN. Example: you can create a data VLAN, for example VLAN 10, and assign user devices, such as PCs and laptops, to this VLAN. This VLAN will carry regular data traffic while keeping voice or management traffic separate. 2. Default VLAN. The default VLAN is the initial VLAN on a switch, often referred to as VLAN 1. When a switch is reset to factory defaults, all switch ports become members of the default VLAN. The default VLAN serves as a conduit for Layer 2 control traffic, but it is recommended to restrict its usage and not allow regular data traffic. Example: when configuring a new switch, all ports are initially members of the default VLAN, VLAN 1. It is best practice to create separate VLANs for different types of traffic and avoid using the default VLAN for regular data traffic. 3. Black hole VLAN. A black hole VLAN is a dummy VLAN created to isolate unused switch ports. All unused switch ports are assigned to the black hole VLAN, preventing any unauthorized device connected to those ports from communicating with other VLANs. Example: assume you have a switch with multiple unused ports. By assigning those ports to a black hole VLAN, for example VLAN 99, you ensure that any unauthorized device connecting to those ports is contained within that VLAN and cannot access other VLANs. 4. Native VLAN. The native VLAN is a VLAN used as a common identifier on trunk links between switches. It ensures that switches can communicate over a trunk link when using different trunking encapsulation protocols. Example, when configuring a trunk link between two switches, a native VLAN, for example VLAN 99, can be assigned. This VLAN acts as a common identifier on both ends of the trunk link, allowing switches to communicate and exchange VLAN information. 5. Management VLAN. The management VLAN is a VLAN specifically designated for accessing and managing the management capabilities of a switch. It is recommended to assign a separate VLAN for switch management to enhance security and isolate management traffic from regular data traffic. Example, you can create a management VLAN, for example, VLAN 20, and configure it as the designated VLAN for accessing the management capabilities of a switch. This VLAN allows network administrators to remotely manage and configure the switch without interfering with regular data traffic. 6. Voice VLAN. A voice VLAN is used to carry IP voice traffic from IP phones. This VLAN allows voice traffic to be prioritized and separated from regular data traffic, ensuring high-quality voice communication. Example, suppose you have IP phones connected to switch ports. By configuring a voice VLAN, for example VLAN 30, and assigning it to the switch ports connected to IP phones, you can ensure that voice traffic is tagged with the appropriate VLAN ID and treated with higher priority. Dynamic Trunking Protocol, DTP, is a Cisco proprietary protocol used to negotiate the status of trunk ports and trunk encapsulation between switches. DTP manages trunk negotiation when the other switch port supports DTP. Let's explore the different trunking modes used in DTP. 1. Trunk. When a switch port is configured with the switch port mode trunk command, it actively sends DTP messages to the remote port, advertising that it is in an unconditional trunking state. This mode establishes a trunk link without negotiation. Example, to configure a switch port as a trunk, you can use the switch port mode trunk command. This ensures that the port is always in a trunking state, and it sends DTP messages to the remote port, indicating its trunking status. 2. Trunk Dynamic Auto. When a switch port is configured with the switch port mode trunk dynamic auto command, it advertises to the remote switch port that it is capable of trunking, but does not actively request to go into the trunking state. The port ends up in the trunking state only if the remote port trunk mode is set to on or desirable. Example, by configuring a switch port as trunk dynamic auto, the local port indicates its ability to trunk, but doesn't request to become a trunking port actively. It negotiates with the remote port and enters the trunking state only if the remote port is set to on or desirable. 3. Trunk Dynamic Desirable. When a switch port is configured with the switch port mode trunk dynamic desirable command, it advertises to the remote switch port that it is capable of trunking and actively requests the remote port to go into the trunking state. If the local port detects that the remote port is set to on, desirable or auto mode, it ends up in the trunking state. However, if the remote port is in non-negotiate mode, the local port remains as a non-trunking port. Example, by configuring a switch port as trunk dynamic desirable, the local port advertises its ability to trunk and actively requests the remote port to go into the trunking state. If the remote port is configured in compatible modes, the local port enters the trunking state. 4. Non-negotiate. When a switch port is configured with the switch port non-negotiate command, the local port is unconditionally considered in the trunking state. This mode is useful when configuring a trunk with a switch from another vendor that does not support DTP. Example, if you need to establish a trunk link with a switch from a different vendor that doesn't support DTP, you can configure the local port with the switch port non-negotiate command. This ensures that the port is unconditionally in the trunking state. Configuring VLANs involves creating them in either global configuration mode or directly under the interface. Let's look at some examples. Example 1. Creating VLANs in global configuration mode. In this example, we create VLAN 10 with the name Sales and VLAN 20 with the name Marketing in global configuration mode. Example 2. Creating VLANs in interface configuration mode. In this example, we create VLANs and assign them directly to interface Fast Ethernet 0/1 and Fast Ethernet 02 using interface configuration mode. Fast Ethernet 01 is assigned to VLAN 10 and Fast Ethernet 0 halves is assigned to VLAN 20. To verify VLAN configurations, you can use the following commands. This command displays a summary of VLAN configurations, including VLAN IDs, names, and associated switch ports. It helps verify that the correct VLANs are assigned to the appropriate switch ports. Example 2. Verifying VLAN membership of an interface. This command provides detailed information about the configuration of a specific interface, including its VLAN membership. It helps verify the VLAN assignment for a particular interface. Trunking involves configuring the communication between switches on a VLAN basis. In this example, we configure Gigabit Ethernet 01 as a trunk port using the switch port mode trunk command. We also change the native VLAN to VLAN 99 using the switch port trunk native VLAN command. Example 2. Verifying trunking status and configuration. The first command displays information about all trunk ports on the switch, including the encapsulation type, allowed VLANs, and operational status. The second command provides detailed information about the configuration of a specific trunk port, including its VLAN and native VLAN configurations. Troubleshooting VLANs and trunking requires checking VLAN assignments, verifying VLAN status, ensuring consistency in allowed VLAN lists, and confirming trunking operational states. Let's explore some troubleshooting examples. This command displays the VLAN configurations on the switch, allowing you to verify VLAN assignments. Ensure that the ports are assigned to the expected VLANs. Example 2. Verifying VLAN status. By using this command, you can check the status of VLANs. Ensure that all required VLANs are active and not in a shutdown state. Example 3. Checking allowed VLAN lists on trunks. This command displays trunk port information, including the allowed VLAN lists. Verify that the allowed VLAN lists on both ends of the trunk match to ensure proper communication between switches. Example 4. Verifying trunking operational states. The first command displays trunk information, including the operational status of trunk ports. The second command provides detailed information about the switch port configuration, including the operational mode. Verify that both switches agree on the trunking operational state. These troubleshooting examples can help identify and resolve VLAN and trunking issues by examining VLAN assignments, VLAN status, allowed VLAN lists, and trunking operational states. By understanding VLAN concepts, traffic types, VLAN types, DTP, and the configuration and verification procedures for VLANs and trunking, you can effectively implement and troubleshoot VLANs in your network, enhancing security, performance, and manageability. Here is a summary of VLAN commands. 1. Show VLAN. This command is used to display information about VLANs configured on a network device. It shows details such as VLAN IDs, names, and port assignments. 2. VLAN ID. This command is used to create a new VLAN with the specified VLAN ID. 3. Name VLAN name. This command is used to assign a name to a VLAN. 4. Interface ID. This command is used to enter the interface configuration mode for the specified interface. 5. Switch port mode access. This command is used to configure an interface as an access port, which can belong to only one VLAN. 6. Switch port access VLAN ID. This command is used to assign an access port to a specific VLAN. 7. Switch port mode trunk. This command is used to configure an interface as a trunk port, which can carry traffic for multiple VLANs. 8. Switch port trunk native VLAN ID. This command is used to specify the native VLAN for a trunk port. 9. Switch port trunk allowed VLAN list. This command is used to define the list of VLANs allowed on a trunk port. 10. No shutdown. This command is used to enable an interface or bring it out of the administratively down state. 11. Exit. This command is used to exit the current configuration mode and return to the previous mode. These commands provide the necessary functionality to create, configure, and manage VLANs on network devices. Please note that the specific syntax and available commands may vary depending on the network device and operating system in use. We hope this video helped you on your journey towards becoming a cybersecurity expert. Remember to subscribe to our channel and turn on notifications so you never miss out on our latest content. And if you found our videos helpful, please give us a thumbs up and share them with your friends and colleagues. Don't forget to check out the links and description for our Anki flashcards and to donate to St. Jude Children's Research Hospital. Your support can make a real difference in the lives of those in need. Thanks again for watching, and we'll see you in the next video.